Hello friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 875. Koko eating bananas. In this video, we are going to practice or share a treatment on binary search. First, I'll read through the problem statement to digest the requirements. And then we look at the procedure, and finally we share the codes. So first, let's look at the problem statement. So there are n pairs of bananas. The S pair has pairs I bananas. The guards have gone and will come back in 8 hours. Koko can decide her banana per hour eating speed of k. Each hour, she chooses some pair of bananas and eats k bananas from that pair. If the pair has less than k bananas, she eats all of them instead, and will not eat any more bananas during this hour. So Koko likes to eat slowly, but still wants to finish eating all the bananas before the guards return. So we are required to find and return the minimum integer k, such that she can eat all the bananas within 8 hours. So this is the main problem statement. So let's look at the examples. So in example 1, so the k is 4, for example, 1 hour, so 2 hour, 2 hour, and 3 hour, right? So similarly, you can interpret the other two examples. Before we look at the procedure, let's also look at the constraints. First, pairs. So this pairs list has length bounded below by 1, in other words, non-empty, and bounded above by 10 to the power 4. And this basically gives us an upper bound on the problem size. And h is larger than the pair's length and less than or equal to 10 to the power 9. And each pair contains less than or equal to 10 to the power 9 bananas. So it has at least 1, right? So this is the constraints. These are the constraints. So now let's look at the treatment here. So here we are going to use binary search. So actually for this problem, you can use other methods, but here let's use this example to demonstrate the use of binary search. So here we're going to take the following procedure. First, I'm going to define a Boolean function. Let's call it can finish all the bananas with rate k in 8 hours, which is going to return if Koko can finish eating up the bananas in 8 hours with rate k. So the second step is that based on the Boolean function defined previously, so we do binary search. So here the two ingredients are the following. First, we determine search space, and then we do the shrinkage. So the above procedure is standard in some sense if you practice a lot of problems. What we need to do here is to demonstrate the procedure. So we want to remark that so the procedure is standard, but the use of binary search can be very complicated, so it's not trivial. So you are welcome to check out our channel or playlist on binary search. There we have more practical coding examples with different levels of difficulty. So with that said, let me do the coding and explain the procedure. So first I'm going to define define the Boolean function. So here I'm going to define this, let's see, can finish. So the rate is k, h is the hour, right? So we want to return if Koko can finish eating all the bananas within k hours, within 8 hours with rate k. So here I'm going to initialize a time variable, right? So I want to check the time usage. So basically, let's iterate. So for banana in pairs, right? So here I'm going to make some division, dev mode. So this is the total bananas. This is the k, the rate, right? So basically, we need a queue hours, and if r is not equal to 0, we're going to need q plus 1 hours. So basically, we are going to do time plus equals q if r equals 0, and otherwise. So we are going to increment by q plus 1. So then let's do a check. If time is larger than h, in this case, we just return false because we cannot finish using the current key. Otherwise, after the for loop, if the time still not larger than h, so we return true. It means that using the current read key, so Koko can finish within 18 hours. So this is the first step. The second step is binary search step. So first, I'm going to determine the searching range, right? So the key for the searching range, so because each pile contains at least one banana, so and also key cannot be 0, right? So the low will be, let's see, low, high. The low is at least 1. So the high, because we at most we can eat up 1 pile, so the will be the max of piles, right? So this is the search range. And next, so let's do the shrinkage. Well, low is less than high. So notice that I'm writing strictly less here. So then the mid will be low plus high minus low, then divided by 2 with integer division. So then what I want to do is that we do the check, can finish. So if we are using this rate, let's see if we can finish within each hour. So if this is true, it means that using this mid, we still can finish. So because cattle want to eat slowly, so let's set this high to be the mid. Notice that this high is still make this Boolean function true, right? This is an important point to notice because it's related to what we need to return. Otherwise, if we cannot finish because this mid is too low, right? So then what we're going to do is low equals mid plus 1. So we need at least mid plus 1. So in the procedure, we know that the high always makes this can finish true. So then afterwards, we're going to return high. So this is the overall procedure, and this piece of code forms a solution format to this specific problem. So before we make any comments, let's first do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So here I would like to comment. So because actually I forgot, when we make this binary search, actually we translate the problem into an optimization problem. We want to find the mean key such that can finish key. This h is fixed, right? It's true. So this is the problem, and also this explains why we can use this procedure. So with that said, I guess that's about it for this specific problem. So binary search, actually sometimes it has 3 typical usage patterns, like you search an element within a sorted list or some list with a specific pattern if not sorted. And this is one. And the second pattern is like this. So you define the Boolean to produce order or monotonicity, and then you do search space and shrinkage. And another one, actually, that's very useful is the bisect module in Python. Sometimes we also use that one. So in real world problems, so that module can be very very useful and sometimes powerful. So with that said, I guess that's about it for this video. Thank you.